All right, guys, so welcome to 10.4, a review. So I made a quick outline of blank notes you could copy. Instead, if you don't do that, you can also just handwrite the notes. I apologize, I know it's a lot, but unfortunately, I am not there to print out the notes for you. Dylan, I miss hearing you say, "Thank you for putting out our notes," every fifth period, and everyone rolling their eyes. Um, but I want to go over some examples. Today is more about box and whisker plots interpretation. So by looking at a box and whisker plot, what is this telling me? So I thought I would share this problem with you about a dunk tank. Now, why did I choose a dunk tank? Oh, that is because probably half of you decided to dunk me brutally in the dunk tank this Halloween carnival. Shout out to AJ for being the first person on his first throw to absolutely dunk me so bad. I will never forget that. And then, oh man, so many of you. It was so fun. But let's go ahead and see what this question is talking about. So I have a dunk tank. So the box and whisker plot represents the number of gallons of water needed to fill different types of dunk tanks offered by a company. So what this box and whisker plot right here is telling me, what it is showing me is the amount of data that I have of all the different amounts of gallons of water needed for different types of dunk tanks. So before I even look at my questions A, B, and C, I really just want to kind of look and reason with what I see from my box and whisker plot. So the first thing I notice is the minimum. So I know I have the smallest amount of water needed is 350 gallons, where the largest amount needed is going to be 750 gallons. Okay, the middle, you would say, so the median is going to be 500. And if I'm looking at sort of that range, where is most of my data? Well, it's a decent IQR. 600 minus 450, okay, that's about 150 difference between, this is where the middle half of my data is. So you could say the majority, 50%, half of your data is between 450 and 600. So that just kind of gives you sort of a mathematical overview of where the majority of your data is. So let's look at our questions. So question A, this is something that you might be asked. So what fraction of the dunk tank requires, what fraction of the dunk tanks require at least 500 gallons of water? 500 gallons of water. So if I were to look and I'm thinking, okay, well, first, where's 500 gallons? 500 gallons is about right here. So I can see that 500 gallons is my median. So if I want to say what fraction of the dunk tank requires at least 500 gallons of water, that's talking about all the values this way, because all of these dunk tanks require at least 500 gallons of water. Now, hopefully you caught on in the video from Friday. It showed you how to sort of split up the fractions of your data on a box and whisker plot. Now, this will always be true. From your minimum to your quartile 1, this will always represent 25% of your data. From your quartile 1 to your median, this will always represent 25% of your data. Now, right now I want you to look at what is the difference between 350 and 450 and 450 and 500. Okay, well, those are different values. So this sometimes throws people off because they think, well, from here to here, that's larger than from here to here, so this should be a higher percentage. No matter what, you have this, you can think of this as split into fourths. A fourth of your data is here, a fourth of your data is here, a fourth of your data is here, and a fourth of your data is here. That is why this represents 25%, this will represent 25%. From Q2 to Q3, this is 25%, and this is 25%. So even though, yes, from here to here, that's a lot larger than from here to here, but this still makes up 20% of your data, 25% of your data, and this still makes up 25% of your data. Because we don't know where that data is. You still have, it's talking about fourths, it's talking about your percentiles. If you need more clarification on that, please video chat me, I'd love to explain it to you. So What this question's asking then is, well, what fraction of the dunk tank requires at least 500 gallons of water? Well, if 500 is right here, and I'm talking about all the values from 500 to 750, well, the fraction of that is going to be 25 plus 25, which is 50%. And sorry, this is really hard to write. And 50% is a half, so I could say that a half of my dunk tanks are going to need at least 500 gallons of water. Now, moving on to B. So I want to know, are the data more spread out below the first quartile or above the third quartile? And how can I explain this? Well, my first quartile is right here, so I'm looking from here to here. I have, this is the difference of my first quartile. So I can find this by subtracting 450 from 350. So the difference from here to here is 100. Let me go ahead and write that. So the difference from here to there is 100. Let's look now at the difference between, it says now my third quartile. So or above the third quartile. So here's above my third quartile, so that would be from 600 to 750. Well, the difference here, 750 minus 600 is 150. So I think which one is more spread out, aka which one has the bigger difference? This one, the third quartile and above, because 150 is greater than 100. So you might be thinking, well, okay, how do I maybe actually answer this? We can say something like this. So for question B, oh boy, bear with me as I figure out, oh gosh, sorry. Hold on, I'm trying to figure out this new, oh, there we go. Okay, so for question B, you could say something like this. Well, I know that the right whisker is longer than the left whisker, which we just proved mathematically because 150 has a longer length than 100. So the right whisker is longer than the left whisker. I could also say that due to that, so you could say, so the data are, you could say, more spread out above quartile 3 than quartile 1. So that's just kind of a sample answer that you could say. You know that from here to here, and you could even just see this visually, this is longer than this, so they're more spread out here than there. And then our last one for C, find and interpret the interquartile range of the data. Well, first, let's see what our interquartile is. So for C, let's see if we can write C we'll write it right here. I know, I apologize. I'm not good at this. I'll get better. I'm sorry. So for C, my IQR, remember, is my quartile 3 minus my quartile 1. And that's going to equal, oh gosh, 600 minus 450, which equals 150. So my IQR is 150. So you could say the middle half of data is spread out. Oh gosh. Oh, here, maybe I can move this for you. Okay. Oh, that's not going to work. The middle half of data is spread out. Or no, you would say the middle half of data varies no more than 150. So I know the middle half of my data can differ no more than 150 gallons. So most of the majority of, I mean, that's pretty close when in scheme of things you have 750 and 350, but you would say something like my IQR is 150. Again, the middle half of data varies no more than 150. So hopefully, I'm sorry for this mess. Hopefully you were able to keep along with this. And here's sort of a next example. So let's look at another example. This one I took from your ebook. It's a really good problem. So it's talking about different buildings. And again, using a box and whisker plot. The box and whisker plot represents the heights in meters of the tallest buildings in Chicago. So right now I'm looking at my data. Wow. So the first thought is it's definitely skewed. If I'm looking at the distribution, is it symmetrical? No. It is definitely going to be skewed. So um, if I want to look at this, I'm thinking, okay, the smallest one is 250. The largest building is going to be 442. The median is 290. Okay, the range is from 345 to 261. Again, not doing any math work yet, just really observing my data and the distribution. So let's go ahead and look at our questions. What percent of the buildings are no taller than 345 meters? Well, let's go ahead and look at, well, where's 345 meters? 345 meters is about, well, actually, it's exactly right here. Oh, that's very large. I wonder if I can make that smaller. So here's 345 meters. So when it says what percent, well, remember, from my minimum to quartile 1, that's 25%. And then from here to here is 25%. And from here to here is 25%. So 25% plus 25% plus 25% is going to equal 75%. What percent of the buildings are no taller than 345 meters? That means that 75%, these are all smaller, they're no taller than 345%. It's kind of a review of inequalities, meaning 25% is from here to here. So yes, it looks like, oh wow, a lot of data is from 345 to 442, but no. That's only 25% of our data is scattered from here to here. Whereas, again, our IQR, the majority of our data is within this box, is within this range. So let's look at question B. Is there more variability in the heights above 345 meters or below 261 meters? So let's go ahead and think about this and see if I can add a text in here. All right, let's make this a little bit smaller. So, okay, so we're going to answer question B. So I'm looking at my data. Well, this is sort of something that you could say. Well, if I'm looking at the right whisker, so it's talking about the heights above 345. So from 345 to 442, that's my right whisker. And I'm talking about below 261. So from 261 to 250, which one has more variability? Well, the right whisker, this one is a lot larger. So I could say the right whisker is longer than the left whisker. So there is more variability The right whisker is longer than the left whisker, so there is more variability in the heights above 345. Really, this variability word, there's a larger range. Variability is talking about where's the range of all your data. Well, here they're going to be a lot more spread out. There's a lot more variety. Variability is talking about variety. Here, from 250 to 261, that's low variability. That is not very much at all. So you could say something like that for B. Well, what about C? If I'm looking at C, well, C is saying find and interpret the interquartile range of the data. So if you want to pause this video and think about it on your own, you can. But again, that's going to be quartile 3, 345, minus quartile 1, 261. Not plus. And that is going to equal an interquartile range of 84. So all this is saying is the middle half of data differs no more than, what number? Yes, 84. So the middle half of data, it's all within 84 meters of each other, which if I'm looking at my problem, that's pretty close. So again, you could say that this is a pretty strong median. I would confidently say that the majority of my buildings were about 293, you could maybe say 300, about 300 yards. Again, this is no black or white answer. It's really just how you can look at a box and whisker plot and make some interpretations from it. So these are some sample answers for this one. Sorry, I'm trying to exit out. I don't know how to end this. There we go. Here are the last examples I want to go over with you. So we've talked a little bit about shape of distribution. If you don't remember what the shape of distributions are, go ahead and take your notes out on that. We had there's left skewed, there's right skewed, and then there are symmetrical. So even though we looked at that with histograms, we can do the same exact thing with box and whisker graphs, plots. So let's look at example 13 really fast. So I want to identify the shape of my distribution and explain. So for 13, if I'm looking at 13, I want to know where's the majority of my data. The majority of my data is to the right, meaning my tail is to the left. So I can make a conclusion that number 13 is left skewed. My tail is left skewed. So this is a little bit different because on histograms I explained it sort of in a different way, but here it's skewed the opposite direction of where the most of the data is. So for 13, most of data is on the right. Again, with our percentages, you could say 1, 2, 3, 75% of our data is really towards the right, meaning this is left skewed. Most of data is on right, so it is left skewed. Let's look at number 14. So I'm looking at number 14 and I'm thinking, okay, here's my median. It looks pretty even from each of my distances. Look at your different dots. So from here to here looks like the same distance from here to here, and then from here to here, from here to here. So for number 14, we would say that this is symmetrical. You could say something like the whiskers are about the same length and the median is in the middle of the box. So that could be your explanation. Let's look at number 15 together. Let me see if I can make this a little bit smaller just so that we can, oh, that made it bigger. Awesome. Let's make it smaller. Okay. So 15, I'm looking at 15. Again, where are the majority of my data? Well, this one, go ahead and think of what you think this would be. And you can pause this video if you need time to think. Number 15 is actually also going to be symmetric, but the explanation is a little bit different. This time, this is symmetric because the whiskers are about the same length. The whiskers are about the same length. So this whisker is the same length as this whisker. And from these quartiles to the median, it's also the same length. So if you were to imagine this on a histogram, it would be like, let me show you. That would be like saying that, I mean, this one really so this is the same as this, which is the same as this, which is the same as this. This one, however, well, this is the same length as this quartile. However, these two are the same, so these two are going to be the same. But what do we know about being symmetrical? As long as the left is equal to the right, these are symmetrical. My reason is just a little bit different. So I could say it's symmetric, the whiskers are about the same length, and I could say the median is in the middle. The median is in the middle, meaning from here to here, it's the same length as from here to here. All right, let's look at number 16, our last one. I'm thinking don't know why that went bigger all of a sudden. So where's the majority of my data? Well, the majority of my data is on the left, meaning that this is right skewed. So most data is on the left, meaning this is going to be right skewed.